Hi kids, we'll be going to this paper discussion. You can look at the first question. First question says an electric circuit consists of three charged capacitors. Capacitance of the capacitors and the values of the charges are given in the diagram, which is Q, Q, C, C, Q, C by 2. At some moment, the plates of the capacitor X are released, allowing them to move freely towards each other. There will be attraction, they will be moving. As a result of inelastic collisions, the plates eventually touch. The amount of heat is released in the system as a result. Initially, this was the situation. Finally, when these two touch, this is the situation. When these two touch, we will be having only two capacitors, but charges we don't know. But we know charges will be redistributing till the potential, this potential difference equals to this potential difference. Let me call it as V. Then charge on this capacitor will be C by 2V. Charge on this capacitor will be CV. But if you look at this plate plus this plate, those are isolated plates. This entire thing is isolated, Q plus Q, 2Q. So this charge plus this charge should be 2Q. From there you will be getting what is the potential now. Then you can find what is the initial energy. Initial energy in this guy is Q square by 2C, Q square by 2C, Q square by 2C by 2. So this was the initial energy. Final energy is half C V square, half C by 2 V square, half 3C by 2 V square. V is this much. So this is the final energy, this is the initial energy. That loss will be going as heat, right? Next, in the given question, match the curve in figure 1 to the curve in figure 2 having the same quality factor in LCR series circuit with AC voltage. Here phi is the phase difference between current and voltage. Yeah, you can see here when applied omega is equals to natural frequency, then you know it will be under resonance. So that's the same thing here. Here phase difference will be 0. Yeah, here power will be maximum at that moment. Yeah, so phase difference, here it is lagging, here it is leading. So the other way of saying it is when omega is tending to 0, when omega is tending to 0, then XC value will be dominating. XC value will be dominating. So voltage will be lagging. Voltage will be lagging, that is the reason it was minus pi by 2. So here voltage will be leading. Anyway, so they are talking about quality factor. Quality factor is defined as natural omega by bandwidth, which will turn out to be this much value wise. Omega naught is 1 by root LC. When you substitute, you will be getting this value. So now I need to see same quality factor. Now if you notice, yeah, there are lot many things which can vary, but let me go with a simple case where L and C are fixed and I will be varying R. If I vary R by keeping L and C fixed, still I can vary the quality factor. Now let me say L and C are fixed quantities. L and C are fixed quantities, and if I keep varying R, now for first situation when R is R1, let me say the curve is like this. For second case it is like this, third case it is like this, and so on. You can see power is maximum for this guy, next for this guy, next for this guy. The meaning is E square by R. So it will be under resonance. Under resonance, it will be power will be like E square by R format, right? Or E RMS square by R, whatever. So if more the R, less will be the power. So this is more R, this is less R, less R, less R, even less R. So this is more R case, more resistance. Now similarly, if I talk about this particular situation where inductive reactance will be dominating. So if I draw the phasor, inductive reactance will be dominating. I into XL will be dominating, I into XC will be less. So net voltage will be in this direction and voltage along the resistor will be in this direction. Now more the resistor, then resultant voltage will be more closer to x-axis, more closer to x-axis. So phase difference will be small. More the resistance, phase difference will be small. So for this guy phase difference is small when compared to the remaining people. So this is more resistance case, this is more resistance case, this is more resistance case. Now with a similar argument you can go for this is the next case which is similar to this case. So 1 is similar to D, 2 is similar to C, and so on, right? So you can fix L and C and you can figure out by changing R. A circular table has radius R and N greater than 2, equally spaced legs of length H attached to its perimeter. Suppose the whole table has a uniform mass density with total mass M assuming the table does not slip, the minimum horizontal force needed to tip over the table. Now I have drawn the top view of the table. For when n is 5. You can just for easy visualization. Now you can tuple in many ways, but out of all the possible ways, you can easily understand the minimum force will be needed when you are going to apply this way and when it is going to tuple about these two legs. This is the three. I am observing from the top view. Actually, there are legs which are touching the ground. So if I apply force like this, it will be toppling about these two legs. So when it is about to topple, torque due to this guy is greater than torque due to weight. Torque due to normal will be 0. Torque due to friction also will be 0 about this axis. So torque due to this guy is going to be F times of perpendicular distance about this axis. This axis is passing through the ground. So from the ground, this force is applied at a distance h. So torque is F into h. Now mg is at a distance. If this is r, this length is r cos pi by n. You can easily prove that. This angle will be 2 pi by n. So half angle will be pi by n. So this will be r cos pi by n into mg. So if this torque is more than torque due to weight, then it will be toppling. The schematic provided has resistors and resistance each of 3 ohms and battery voltage is 48 and all ammeters are ideal. Then what are the readings in the ammeters? So there are lot many things here. Let me just explain one by one. I will be assuming this as 0 volt for easy solving. Then this is going to be 48. Remaining I don't know. If I assume this is x, then this value will be x because this is resistance less. If this is y, then this will be y. And if this is z, this will be z. Now once I got all the potentials, how many potentials are there? 0, 48, x, y and z. In fact, this resistor is between z and z, so no current will be flowing through that we can easily conclude. Now I will try to redraw the figure just for easy calculation. 0, 0, 48, x, y and z. All the resistors in between them I am going to put between 0 and z there is 3 ohm. Between y and 0 there is 3 ohm. Between y and x there are 3 ohms, so it will become 1 ohm. So when I redraw the figure, it is going to look like this. I didn't draw this resistor. That will be between 0 and 0, so no use. Z and z, so no use with that. Now by symmetry you can conclude. Even if you remove the connection, battery won't be knowing about it. Now once you do that, you can calculate equivalent resistance is 6, so you can easily calculate the current. Similarly, you can calculate the resistance and current. This current will be splitting into 2 parts. Those also you can calculate. Now once I calculate this, I am going to put them back here. Between 48 to z there is one resistor, so that current will be 8. Between 48 and x there will be 7. So similarly, this is between x and y. Totally it is 6. So in this one it will be 2, in this one it will be 2, in this one it will be 2. Or else you can find the potentials. Once you find the potentials, you can put them back here, then you can get the currents easily. Or out of 7, 2 is going this way, so 5 will be going this way. So rest of the stuff you can do. Maybe if you can't copy from here to here, you can find the potentials at individual points and you can substitute it back, and then it's easy to calculate the currents. Anyway, if you want to find current in the resistance-less wire, you have to use KCL. V equals to IR won't be much help. A particle is constrained to move on the inner surface of a frictionless parabolic bowl. It is a parabola. When you rotate parabola, you will be getting parabolic bowl, whose cross section has the equation z equals to kr square. There is parabola. The particles begin at a height z0 above the bottom of the bowl with horizontal velocity v0 along the surface of the bowl. Acceleration due to gravity is g. Then the value of v0 for, okay, we will go with the option. So we will go with the first option. The value of v0 for which it will perform horizontal circle. So if it is performing circular motion, then normals this component should be providing centripetal, normals this component will be balancing mg. If this is theta, this will be theta, this is 90 minus theta. So n sin theta will be providing centripetal, n cos theta will be balancing mg. Tan theta you can get by math by taking differentiation slope, right? So you can take the ratio, then you will be getting tan theta. You can substitute tan theta from here, and when you solve it, you will be getting this much. So v0 is square root of 2z z0. So option A is wrong because they have given root z z0. So it would have been correct if it was root 2g z0. Now if velocity is greater than this, then it is not going to perform circle. For this particular velocity given z0, they have given z0. At this z0, if you throw with this particular velocity, it will be performing circle. If you throw with more than that velocity, maybe if it will be moving, it will be moving along it, and it will be going up and it will be coming down. Something is going to happen because forces will be unbalanced, at least in vertical direction or along this direction. Anyway, we don't deal about forces. We'll always check with conservation laws. If we can do with conservation laws, we'll do them, or else we'll go into forces. Now, though there is normal, torque due to normal about this axis will be 0. So I can do conservation of angular momentum about this axis. Torque due to normal about any point, if you calculate, torque will be this way. Its component in this direction is 0. In this direction is 0. So if torque component along some direction is 0, then we can do conservation of angular momentum along that direction. Similar to momentum conservation. If the net force, if the force is 0 if the net force is 0, we can do conservation of momentum along any direction. If the force is 0 along some particular axis, then we can do conservation of momentum along that particular axis. In the similar manner, torque is 0 about this axis, so we can do conservation of angular momentum about this axis. Now, initial angular momentum is this much, r0 into mv0. Now, at any moment when its distance is, when it is at a distance r and its velocity along the surface is v. Now, there will be some velocity like perpendicular to the surface, I mean not into the plane, whatever. So, initially velocity was this way, but later on there will be two components of velocity, one this way, or one like this one, and the other one will be perpendicular to this. But this is the only guy who is going to provide angular momentum. Now, when it is going to reach the topmost point, this velocity is going to become 0. The other way of saying it is, when I write energy conservation, this term is not going to come into picture. But if I write at any other moment, the term also will be coming into picture. But in this final moment, when I want to check what is the maximum height reached, it won't be coming into picture because this component is going to become 0 when it is reaching maximum height. Only this component will be surviving. In fact, velocity can never become 0 because angular momentum conservation we already know. So, energy conservation, initial kinetic energy plus potential energy equals to final kinetic energy plus potential energy. Then we need to solve both of them. I have taken this equation. Instead of v square, I substituted from here. Then I manipulated it to get the answer, which is independent of z0. So, no matter what is z0, if you throw it some particular velocity, it is going to go to the same maximum height, which is v0 square by 2g. Then option C and D, it is simply SHM question. So, option C and D is, if you just take it slightly here and if you leave it, it is going to perform SHM, and what is the time period. So, basically that is going to behave like a small circular arc. In that case, torque will be equals to mr square alpha, I alpha. From there you can look, it is of SHM form. So, time period will be this much. Now, throughout this, I assumed radius of curvature of that part is r. But what is the radius of curvature of parabola here? There will be many ways of finding it. You can find it by yourself. But those who want to find radius of curvature, maybe you can take help of this thing from your doubt clearance. If you send the parallel rays, they will be meeting at the focus. Once you understand that focal length is a, then radius of curvature will be 2a. So, that way you can find radius of curvature and you can substitute it to get the required answer. A cart for studying uniformly accelerated motion is driven by a weight as shown in the figure. A descending weight of mass m rotates the rear wheel axle via a rope passing over the pulley with the rope sufficiently wound around the axle. Initially, the weight is at a height h above the cart. When released, the cart starts moving. Each of the four wheels of the cart has mass m1 and radius r1. The rear and front axles have mass m2 and r2. The wheels and the axles are made of solid homogeneous cylinders. The motion of the weight is guided by smooth vertical tube. The mass of the cart without the weight, axles and wheels is negligible. The mass of the pulley, friction of the weight inside the tube and rolling resistance of the wheels are considered negligible. That is, like, internally there was no resistance, which is going to take up the energy. Now, once we understand that, we need to, if you look at the options, they are talking about acceleration of the cart. speed of the cart. So basically when this guy is moving this way, he will be rotating this. When he is rotating this, friction will come into picture. So the entire thing will be moving this way also. So if you ask me what is the direction in which he is moving, he will move down as well as this entire thing will be moving forward. So this guy will be moving down as well as forward. This guy will be moving forward and rotating. Now this also in the same manner. Tension, acceleration and speed. So there are many bodies. So the better option for us would be going energy conservation rather than writing F equals to ma. Yeah. So if I assume this velocity is y dash, if this guy has fallen a distance y, his drop in potential energy will be going as kinetic energy for this guy plus this guy plus this guy. So his kinetic energy is half m into, this guy will be going down as well as moving forward. This velocity is y dash square and this velocity is x dash square. So its resultant velocity will be root of y dash square plus x dash square. So half m into his velocity square, kinetic energy of this guy, plus wheel's kinetic energy. Now it is pure rolling about this point, so I can go with half into y about this axis into omega square. But 4 such wheels are there. And axle. Now axle also fixed to this one, like so I can say like it's, so this guy plus this guy total kinetic energy is kinetic energy, just purely rotational kinetic energy about this axis. So I need to find moment of inertia of this guy about this axis, that is going to be mr square by 2 about this axis plus parallel axis theorem, half I omega square, but there are 2 axles, right? Now once you understand this, it looks like there are many variables y, x dash, y dash, omega, but we know one thing, this guy's velocity in this direction is y dash, y dash. So along the string the velocity is y dash, so this velocity also should be y dash, that is r2 omega should be y dash. Now in the similar manner, this bigger one is pure rolling, so this is x dash, so r1 omega should be x dash. Sorry. Now as I have seen from the options, it is coming r2 by r1 and stuff, so we are going to take eta as r2 by r1 just to make the calculation look easy. If I take this, then if I take the ratio, I can say like y dash is eta times of x dash, then I will be substituting it back wherever I am converting everything into x dash. I am converting everything into x dash, y dash as well as omega as well as y, because they are asking velocity of the cart and acceleration of the cart. Now once you see this, then you can differentiate it to get the acceleration, or from here you can see the speed also. From there you will get option A and B. Then once you get the acceleration x dash, x double dash, then you can find y double dash also. Then if you write F equals to ma for this guy along this direction, then you will be getting tension, right? If you want to write F equals to ma, torque equals to I alpha, you can write, but there will be many equations involved. The better option is to go with energy conservation and reduce the number of variables. And I am attaching a PDF where I have solved this in doubt clearance folder somewhere, where I will be solving using force method as well as energy method. I think there are a couple of questions where I will be doing that. I think in Newton's laws also I will be doing that, I guess. In the circuit shown, the switch S has been closed for a long time. At t equals to 0, the switch is opened and it remains open for time t, after which it is closed again. Then they are asking voltage across 100 kilo ohm and time constants. So if I want to calculate voltage across 100 kilo ohm, I should calculate the current. See, now it is opened for some time, then current will be flowing like this, so it will be getting charged. Once it is getting charged, then the equation is going to look like CV into 1 minus e power minus t by tau. Tau here is total R into C. But once you close this, it is going to be discharging, so then the time constant is going to be R into C. So time constant while discharging is this much, while it is discharging is this much. Now while charging, if this is the charge at any time, then when you differentiate it, you will be getting current at any time, but we need at this particular time capital T. When I substitute capital T, I will be getting this much. From there you will be getting option B, because when you multiply this with 100 kilo ohm, you will be getting the potential difference voltage drop across 100 kilo ohm. Time constant of the circuit is 1.5 seconds after this. Now before T, time constant is 1.5. After closing the switch, then the time constant is only 1, so option D is wrong. Now I need to find what is the current through discharging. Now what was the charge on the capacitor initially? It was this much, I mean when I close the switch initially while it is discharging. So this was a constant charge at that moment, which is going to reduce like e power minus t by tau form. So now from here, after closing the switch, let me say x time has been passed, then total time from the beginning is capital T plus x. But time in discharge is only x. So once you know time in discharge is only x, then the charge at any time will be initial charge into e power minus x by tau. But this q is this much, you can substitute it back, or you can differentiate it to get the current. Now I into 100 kilo you should calculate. So I into 100 kilo, I value I can substitute it back. 100 kilo, I value is this q, I need to substitute this q, then e power minus x. What is minus x? Minus x is capital T minus small t. Then it's only about mathematical thing. So basically it is charging for some time and discharging for some time, only that much. 1 mole of ideal monatomic gas follows a cyclic process. Choose the correct options. 1 mole monatomic, 3 degrees of freedom, and they have given some things. So let me just explain one by one. Okay, so this temperature T0, this is V0 square, this is 3 T0, this is 2 V0 square. Now let me say the pressure here is P0. Now at constant volume, temperature is becoming 3 times, so pressure will become 3 times. So this is fine. Now you can write this line equation, that line equation will be this much, and this is going to become 2 V0 square. If this is going to become 2 V0 square, temperature is going to become 2 T0. Then by using PV equals to nRT, volume is becoming root 2 V0, so pressure will become root 2 P0, only then temperature will become 2 times of P0. Now in the similar fashion, you can write this line equation, and you can see temperature is going from, pressure is, volume here was V0, volume here was root 2 V0, so you can substitute 2 V0 square, so temperature is going to become twice of this, so it is going to become 60 knot. Once you get this temperature, you can find this pressure also. So temperatures you will be finding using the line equation, pressures you will be finding using PV equals to nRT. From there you can see option A will be correct. TB plus TC, that is 8 T naught by 2 is 4 T naught. Then whether it is this case or this case, V square by T is constant, so it is polytropic process. When you convert V square by T into PV power X format, X will be minus 1. Then molar heat capacity is going to be F by 2 or CV minus R by X minus 1, X is minus 1. So molar heat capacity in both the processes 2R. Now if I multiply with N delta T, this will give me change in internal energy, this will give me work done. Work done is going to be N R by 2 delta T. Delta T in case of D to C was 3 T naught. Then you will be getting the right option D. A cubical container has two fixed vertical walls and two walls which can move freely about one of the horizontal edges. The right wall can rotate about the upper edge and the left wall can rotate about the bottom edge. Water is filled. So if the water is filled, this one will try to rotate like this and this one will try to rotate like this. So you are applying a force here and you are applying a force here to stop that. Given that the cube is at rest on a rough horizontal surface, then what is the direction of friction? What about the normal reaction? Now, as everything is in equilibrium, now net torque should be 0 on the walls. Now, for this guy, I will be taking torque about this axis so that I can avoid these hinge forces or whatever it is. So, anyway, P0, torque due to P0 is going to get cancelled. So, I am neglecting atmospheric pressure. So, I need to calculate what is the torque on this wall due to pressure force about this axis. So, at a distance y, pressure is going to be rho gy and area of the strip is going to be L dy. That is going to be the force, but I need to calculate torque about this point. So, if this is y, this will be L minus y. So, perpendicular distance is L minus y, force is this much, I need to integrate. That should be balanced by torque due to this guy, that is L into F2. From there, I will be getting F2 value. Now, similarly, if I want to calculate torque due to pressure force here, again I will be taking at a distance y, pressure is this much, area of the strip is this much, perpendicular distance is this much. When you integrate, you will be getting the torque, which should be balanced by torque due to this guy. From there you can see F2 is F something by 6 and same thing by 3. So basically this force is less, this force is more. As we know it is at rest, then friction has to be supporting this guy. So F by 6 plus F by 6 will be F by 3. So friction will be in the rightward direction. Now As it is not moving, net torque should be 0 about any point. You can choose your own point. You can take either center of mass. If you take center of mass, torque due to this guy and this guy will be getting cancelled. Then torque due to this guy, if it has to be balanced, that should be balanced only when the normal shifts this way. Or you can take torque about bottom point also, whatever it is. So you can make net torque 0 and you can understand normal will be shifting rightwards. At the center of the tube with radius r, a source emits charged particles. Each particle has charge q greater than 0 and mass m. All the particles are emitted from the source in the plane of the drawing with same speed v, evenly distributed in the upper half of the tube. So there are particles only in the upper half of the tube. A detector of length L, which registers the total number of particles that reach it in 1 unit of time, is fixed on the surface of the tube as shown in the diagram along the entire tube. So if the tube is like this, this entire thing is also like this. But anyway, we will look into only one plane, because whatever happens in one plane, the same thing will happen in other planes also. For what values of B will the detector readings be at their maximum possible values? Interaction between the charged particles and radiation is negligible. Now, so if I see how the motion is going to look like, now if I talk about this guy, velocity is this way, magnetic field is this way, so force is going to be this way. Velocity is this way, force is this way. So this guy is going to perform this circular motion. Similarly, this guy, velocity is this way, v bar cross v bar, force is this way, he is going to perform this circular motion. Now this guy, v bar cross v bar, center is this way, so he is going to perform this circular motion. Now when the radius is small, it is not going to hit here, so it is not going to register anything, the detector. But that is when the magnetic field is more, radius will be less. Radius is mv by qb, right? More the magnetic field, less will be the radius. So if I keep reducing the magnetic field, radius will keep increasing. So till mv by qb, is less than r by 2, or 2 times of mv by qb is less than r, it won't be hitting there. So till the magnetic field is greater than this, it won't be hitting. So from there you can conclude option D is wrong. Now if you keep reducing the magnetic field, there will be a situation like this. Now the darkened ones are the ones only there. Now the lighter ones I have just drawn for my understanding. If there are particles in all the directions. But if there are particles only in the upward direction, those particles are going to perform only these circular motions. Now out of all these real ones, only some are going to hit here, if you notice. In fact, you can see each one, whichever is hitting, is going to travel at an angle 180 degrees. So all the time taken will be same. So all are going to hit at the same moment. So this is the least magnetic field. When you keep reducing the magnetic field, this is the first time you can see detector detecting something that will happen at this magnetic field. Now what will happen if you even reduce the magnetic field? The radius will keep increasing. So the ones which were hitting before, now they won't be hitting, but new ones will be hitting. So this entire thing is in like 180 degrees. So you can see like the particles have been shifting this way, or the ones which are colliding. Now the ones which were here, they are going to collide. So you can see like if you keep reducing the magnetic field, this shift will be keeping on happening. And we want to talk about only extreme. So I will be seeing when will this guy is going to hit. So when I keep increasing the radius, or if I keep reducing the magnetic field, it will keep increasing the radius. Then this last circle is going to hit here. Now I will see when is that going to happen. This last circle. So that will happen for the velocity for this guy. If the velocity is this way, magnetic field is this way, v bar cross v bar, force is this way. So he is going to perform circular motion like this. He is going to hit here. This angle was given 30 in the question. Now if this is 30, this will be 60. Now suppose this is the center somewhere here. Now as these two radius are equal, these two angles should be equal. This already 60 we concluded, so this will be 60. If these two are 60, then this one also will be 60. So in fact this will be here, if I have drawn it correctly. First I don't know whether it will be here or not, so I can't conclude. So I have drawn it, then I understood like all are 60 degrees. So all these three lengths are same. the other way of saying it is pink radius is same as white radius. Pink radius is same as white radius. So magnetic field mv by qr. So till here, when I keep decreasing the magnetic field from 2 mv by qr, when I keep decreasing the magnetic field from 2 mv by qr to mv by qr, the same number of particles will be hitting, but the particles hitting are not the same particles every time, they are different particles. Now after this, if I even reduce this, then this particle is going to hit here, so only this much part will be detection, whatever. But whatever particles are hitting, they are going to hit after the exactly same time. By symmetry, you can conclude that. Figure shows the circuit of potentiometer. The length of potentiometer wire AB is 50 cm. The EMF of the battery is 4 volt having negligible internal resistance. Values of resistance R1 and R2 are 15 and 5 ohm respectively. When both the keys are open, then L point is obtained at a distance 31.25 from end A. Given the resistance of the wire is 10. Potential gradient of the wire when K2 is open and K1 is open. The balance length when K2 is open and K1 is closed. So let me talk about both the situations. First situation was like this. When both are open, that this is how it is going to look, and it is balancing at 31.25 centimeter. For 50 centimeter resistance is 10 ohm, so for 31.25 you can find that 6.25, so the rest will be 3.75. Now it is no deflection, so I can say like this circuit has nothing much to do if I want to calculate the current. Current will be given by voltage by total resistance. Total resistance is 10 plus 15, 25. So current will be 4 by 25. So this potential difference will be I into R, which is 1. So this potential difference will be same as this potential difference. That you can easily convince yourself. If this is 0, this will be 0 because no current is flowing through this. This is E. So potential difference between these 2 points is E, which is 1, we already know. From there we can conclude this EMF is 1. Anyway, that's not their question. Their question was potential gradient, that is what is the potential difference across 1 unit length, 1 centimeter length. So for 1 centimeter resistance is this much, current into resistance is voltage difference. Potential difference across 1 centimeter is 0.032. Now we will be utilizing this information. E value we have already calculated. When I put it back, they are saying when K2 is open and K1 is closed. When K1 is closed, then the potential difference across R1 will be 0, so no current will be flowing, so I didn't draw that. Now also, as it is 0 deflection, I can simply calculate this current like voltage potential EMF by total resistance 4 by 10. This potential difference should be equals to 1, so this resistance should be 10 by 4. That resistance will be 10 by 4 when its length is 12.5 centimeter. The blue of sky and red of sunset are due to phenomena called scattering. When sunlight passes through the Earth's atmosphere, much of the light is picked up by air molecules and given out again in some other direction. Experiments show in agreement with the theory of scattering that the shortest waves are scattered more readily than the longer waves. To be more specific, the scattering is inversely proportional to the 4th power of wavelength. Scattering is inversely proportional to 1 by lambda power 4. For every 10 violet waves scattered from a beam, there is 1 red wave. Scattering of different colors will be in the ratio given below. Wavelength of yellow light approximately, and scattering of wavelength corresponding to threshold wavelength of photoelectric setup. Okay, so yeah, so you can see here scattering is inversely proportional to lambda power 4, or scattering into lambda power 4 should be constant. So scattering for violet into violet wavelength power 4, scattering of red into red wavelength power 4, that should be equals to any other scattering into wavelength power 4. Yellow scattering is 2.5 given, its wavelength power 4. When you equate either these two or these two, you will be getting some answer, but yeah, approximately it lies somewhere here. Now they were talking about photoelectric setup on work function 6.2. So 6.2 electron volt photon. So you need to calculate the wavelength. That wavelength is going to be 2 into 10 power minus 7 when you calculate. So you need to calculate what is its scattering value, and they said its scattering value, if it is 10 times of violet color scattering, sorry, n eta times of violet color scattering is 10, so it is 10 times of eta. So if you equate these two, first one and the last one, or last one and the second one, whatever, you will be getting some answer, right? Two particles with positive charge E and mass m, and a third particle with negative charge E minus E and m by 2 move in circular orbits maintaining the configuration of isosceles triangle. The planes of the particles orbits are perpendicular to the base of the triangle. This is base of the triangle, so circular motion is happening this way. Now you need to find the ratio of this guy's radius to this guy's radius and a ratio of this length to this length. Now if you calculate the center of mass location, in fact, if you want to see force on this guy, due to this guy the force will be attractive in nature, due to this guy it will be repulsive in nature. So one force is this way, one force is this way. Now center of mass of these two people will be here, so I can replace these two with m by 2m here. So 2m and m by 2, I need to calculate center of mass. Center of mass will be closer to heavier guy. In fact, I can easily show you, if this distance is x by 2, this will be 2x, because 2m into x by 2 should be m by 2 into 2x, right? So ratio of, okay, so basically what is happening, this guy is going to perform circular motion about this line, about this as center. That in fact you can see this force plus this force resultant will be this way. So this guy will be performing circular motion this way, symmetrically this guy also will be performing circular motion this way, but by the time he performs one full circle, this guy will be performing one full circle because center of mass won't be moving. So by the time he will be performing half circle, this guy will be performing half circle. In fact, this triangle will be flipping about this axis. The entire thing is rotating about this axis. So you can see like it is rotating about this axis. So ratio of this radius to this radius is x by 2, this radius is 2x. So you will be getting 1:4 or 4:1. Then they are asking what is the ratio of L and R. That will be, so basically resultant of these two forces should be this way, then only he will be performing circular motion, right? That should be providing centripetal. So this force, horizontal component should be balanced by this force. This force, vertical component will be giving a centripetal, horizontal force should be getting cancelled. So this horizontal component will be cancelled by this force. From there you will be getting the required answer. A steel girder is planted securely between two sides of a ravine in order to provide a bridge. The total cross-sectional area of girder is 30 cm square and the length of the girder is 4. Installed at a temperature, the temperature is now raised, so its length tries to increase but it is not allowed to increase, so there will be stress and stuff. So they are asking what is the force exerted by the girder. This is a straightforward question. Area, length at 5 degrees Celsius, change in temperature, Young's modulus alpha. So when you heat it by 15 degrees more, its length is going to become this much, if it is freely expanding, but it is supposed to be this much length, but when you look at it now, its length will be 4 only, because its earlier length was 4, which was, if you heat it naturally, like if you allow it to expand, then it would have expanded by this much, but its length is 4 only. So basically what is the change in length? Naturally it will be the length, but its new length is only 4, so change in length is this much. Once you know change in length, this is the original length and this is the change in length. Once you know change in length and original length, you can calculate the value. Anyway, when compared to 4, this is very small, so we will be generally neglecting it. A closed cylindrical soft drink can of height 12 cm and radius 4 cm is filled up to height 9 cm. Volume above liquid has air at a pressure 10 kilopascal. Soft drink is incompressible and has specific gravity pointed. Taken far away from the celestial bodies, that is acceleration due to gravity is not there. Where the can is rotated about its axis with a constant angular velocity, it exerts a pressure on the curved surface. How much is that? So when you take can with whatever cool drink, soft drink, and when you rotate it, first thing is you need to understand it is going to take this orientation. Now how you are going to understand that? That's one way is when you try to rotate, every particle has to rotate. So if every particle has to rotate, initially viscosity should be there for the rotation to happen. So there should be some centripetal force. So basically there is pressure force. Now this pressure, if there is pressure force in this direction, there will be pressure force in this direction also. So if on this water molecule, if there is pressure force in this direction, it will go this way. It will go this way. So it won't stay there. Or the other way of saying it is, you can see like this is the normal derivation. In this normal derivation, when you put z tending to 0, y will be tending to infinity. So for any x, y value will be infinity. For any x, y value will be infinity. So it is going to take this orientation. Once you understand this, you can see like there is a gap here. You can find that radius by volume conservation. Initial volume of the soft ring equals to final volume of the soft ring. When you use that, you will be getting this gap radius is 2. Now, if you want to find, and they said air is here, air is having pressure 10 kilopascal, then you can write this guy's net force on this guy. His center of mass is performing circular motion. So net force on that guy is this pressure force minus this pressure force, that equals to mass times of acceleration of center of mass. This element length is 4 minus a centimeter, that is a is 2 you will be getting. So 2 into 10 power minus 2, and its center of mass is here, which is at 3 into 10 power minus 2. When you write F equals to ma for this guy, for the system, then you will be getting that pressure by the wall is 2 into 10 power 4. An ornament is lying at the bed of the pond of depth 8√3 meter. The pond is full of water of refractive index √3/2. A diver at the surface of the pond is trying to look at the ornament such that her line of vision makes 30 degrees with the surface of the pond. Perpendicular distance of image of ornament from the surface of the water. Now this kind of question already came in some of your revision material. There I have just shown the derivation and directly used the formula, but here we will be deriving it for this particular question, so that it looks like we didn't do derivation, we just solved it naturally. Now object is here, and but some diver is observing at an angle 30 degrees here. If this is 30, this will be 60. Now by using Snell's law, if this is 60, this is 45, you can get that, and this distance is given. So basically, so when you try to draw two rays, this ray will be going this way, the next one will be going this way. When the observer is seeing these rays, the observer will be feeling these rays are coming from here. So if this is the object distance, this is the image distance. This is what we should find. Now I can see this big triangle. This angle is I, 45 and 60. But for the next line, that angle will be changing. So I am calling it as I and R, so that I can see like how the change is going to happen. If this is I, this is going to be I. If this is R, this is going to be R. Now if I look at this triangle, I will be getting tan R is x by y, tan I is x by y. This is fixed value. I mean, this is fixed value, this is also fixed value. We already know that. For this fixed value, this answer will be fixed value. Right. So if I take those two triangles and if I use tan, I will be getting this much. Now for both the triangles, for green triangle or for yellow triangle, the small increment in this is going to be same. So d small x is same as d capital X. I am taking this big triangle, and I am seeing if this angle is changed by small amount, how is this length going to change for a fixed value of this guy. Now similarly, I am going to take this smaller triangle for a fixed value of this. If I change this angle by some amount, how this is going to change. So then you will be getting this much, but I need the relation between di and dr, so I will be taking Snell's law and I will be differentiating it. Then instead of dr, I will be substituting √3 di. Now small increment in capital X or small x is same, so when you equate them, you will be getting the required answer. Or if you want to remember the result, you can look at the derivations here, right? Thank you.